Hello everyone. In a couple of previous videos, we have been exploring some trends and building blocks that had an enormous impact on artificial intelligence. Now that the building blocks are in place, we have explored abstraction levels, looked into programming paradigms, and revisited operating system and architectural aspects of our machines, as well as the main driving force behind some inspiring trends that had enabled AI to take over our lives by storm. Now we are in a position to define artificial intelligence and its subcategories. But before going to a comprehensive definition of I want to emphasize using a line or two on the data explosion enabled by these trends, which resulted in generation of huge amounts of data from different sources around the globe. This data is fragmented as it is obtained from different sources because complex challenges of the society don't get solved using a single source and modality. Therefore, we need data science techniques, including data cleaning, feature engineering, and statistical analysis for handling these diverse data types to extract meaningful insights from them. This data can be extraordinarily useful, and this is where AI can help in harnessing full potential of applications solving different problems. So AI is a broad field of computer science that focuses on creating machines or systems that can perform complex tasks that typically requires human intelligence. As John McCarthy defined AI in 1955 as the science of making machines do things that would require intelligence if done by humans. So we are talking about machines to mimic human intelligent behavior that enables machines to perform these complex tasks. As all fingers are pointing towards the notion of intelligence in humans, we need to understand the key aspects of human intelligence in order for us to grasp the idea of artificial intelligence. Key aspects of human intelligence include reasoning and problem solving. Both are crucial for navigating daily life and achieving success in various fields. For example, if a car is low on gas and the engine sputters, we can reason that the car is likely out of gas and needs to refill. A student weak in some topics, let's say in mathematics, he needs to hone his skills, problem solving skills in those areas. Then we have learning and adaptation. Learning and adaptation are intertwined processes where individuals or systems modify their behavior or understanding based on experience to better interact with their environment. For example, a child learning to ride a bike, a student learning a new language, a programmer learning a new coding language. And adaptation is when humans adjust their behavior under various circumstances. For example, the child learning how to ride a bike needs to change his behavior in order to learn how to ride a bike. Then we have perception and interaction. Both are fundamental processes that shape our understanding of the world and our behavior within it. For example, recognizing a similar face, understanding spoken language. An example of interaction is having conversation or playing a game. Okay, so a comprehensive definition of artificial intelligence must include these components of intelligence altogether. So now let's have some formal definitions of these components of intelligence. Reasoning and problem solving is the ability to infer new information from what is already known, i.e., deductive and inductive reasons. Problem solving is the process of finding a way to reach a desired goal under constraints. That is, identifying, analyzing, generating solutions, and ultimately implementing and evaluating results. Now comes the learning and adaptation. Learning involves acquiring new knowledge and skills, while adaptation is the process of adjusting to changing circumstances. Perception and interaction. Perception is the process of interpreting sensory information to create meaningful experience, while interaction is how we engage with our environment. So, a comprehensive definition of artificial intelligence must include these components of intelligence altogether. So, AI is not merely automation, but pursuit of machines that can attain these components of intelligence. So let's dive deeper into what's artificial intelligence. Well, the first thing that comes to mind while defining artificial intelligence, it must have something to do with thinking. So let's start defining our comprehensive definition of AI by saying that it has to do something with thinking, whatever that might be, but the definition of AI must be broader in the context of computer science and engineering. So it's not only about thinking, it's also about perception, and it's also about action. Further expanding the definition, we also need to talk about models. Models targeted at thinking, perception, and action. These are models of thinking that understand the problem, explains the past to predict the future. It can be physical models, statistical models, or simulation models. Okay, but when we talk about models, we need to have representations. So AI is about representations. Representations that support models targeted at thinking, perception, and action. You must ask yourselves, or I should say, you should ask yourselves, why representations are important. Let's have a few words about why representations are important. Representations are important because it provides data abstraction to hide irrelevant details, allowing AI models to focus on essential features. Good representations enable efficient processing while reducing computational cost. Well-designed representations can significantly improve performance, accuracy, and robustness of our AI model. Other quickies about benefits of representations are: good representation makes relation clear between objects. Good representation expose natural constraints while suppressing irrelevant details. Good representations are transparent, complete, concise, fast, and computable. Let's have an example of representation for a game that we played as a first grader. The problem of the farmer, fox, grain, and the goose. The farmer has in his possession an old boat that can only take one object in addition to the farmer, and the problem or the game is to cross to the other side of the river. The constraints are if left alone, the fox will eat the goose. If left alone, the goose will eat the grain. So, what representation will provide all the above mentioned benefits? The first thing that comes to mind about the right representation is the location of these objects. So, let us draw. This is a situation, also called an initial situation. Then we have other situations, also called intermediate situations. We know that the farmer can execute a movement from one situation to another between legal situations where somebody doesn't get eaten by somebody else. We move from one situation to another until we reach the goal state. And then we have a final situation where the farmer successfully crosses the river. We move from one situation to another until we reach this goal state or the desired state. So, some questions that we need to ask: how many situations do we have? Well, 2 is power 4 because we have 4 objects, 16 situations. Why 10 situations are mentioned here? Well, because other situations are illegal, where somebody gets eaten by somebody else. So hopefully by using this representation, the farmer is able to move everybody to the other side of the river. There are other examples that include water jug problem and cannibal missionary problem. You can go out and check it. So as we said earlier, that having a good representation exposes constraints of the problem. So now add to our definition of AI: constraints exposed by representations that support models targeted at thinking, perception, and action. But that definition is still not complete because ultimately we would require to build programs. So, artificial intelligence is about algorithms enabled by constraints, exposed by representations that support models targeted at thinking, perception, and action. So algorithms can also be thought of as methods, procedures, or programs. Okay. So is our comprehensive definition of artificial intelligence complete? Well, much of our intelligence has to do with thinking, perception, and action with loops that tie these components together. If we would separate these components or disjoin these components to perform separately, that won't be intelligence. This is a comprehensive definition given by Henry Patrick. Now that we have defined artificial intelligence comprehensively, we want to talk a little bit about the subcategories of artificial intelligence. Let's move on to having a few words about subcategories of AI. AI is a broader field that encompasses various techniques and subfields. AI is aimed at creating machines capable of mimicking human intelligence, including rule based systems, knowledge representation, logical reasoning, planning, robotics, computer vision, natural language processing, and machine learning. We will, however, look into a few that strictly lie under the fold of traditional AI. For example, we have rule-based systems. Rule-based systems are best at solving problems where domain knowledge can be explicitly defined through logical rules, and decision-making process must be transparent, consistent, and interpretable. Then we have knowledge representation. It is used to organize and structure information so machines can understand, reason, and use to make intelligent decisions. One of the major paradigm in traditional AI is solving problem through state space search. Problem solving through state space search relies on symbolic representation, logic based reasoning, and deterministic algorithms to explore possible states and actions in order to reach a defined goal. Then we have game searching, also called adversarial search. This has come from the word adversary. So this is a class of algorithms that enable decision making in competitive environments by exploring possible moves, predicting opponent responses, and evaluating outcomes to select optimal strategy. All of these classes of algorithms come under the traditional fold of AI that are mostly constraint aware. Either these algorithms explicitly reason about constraints or handles them directly in algorithms. Unlike these traditional AI algorithms that relies on fixed rules and constraints, some problems are better solved by learning from examples or past experiences. This is where the subdomain of AI machine learning comes into action. As defined by Arthur Samuel in 1959, one of the best definitions, ability in computers to learn without being explicitly programmed to do so. Essentially, these data-driven algorithms can learn patterns from data to handle complex, uncertain, or changing environments more effectively. A few examples or applications in this domain are email spam versus not spam, classification, recommendation engines, natural language processing, diagnosing disease from x-rays, and recognizing digits or faces. If these were to be implemented using traditional AI algorithms, we would have required a web of if-else or rule-based constraint-enabled systems. That becomes too complex to handle. However, there may arise situations where data is too complex, too large, and high dimensional. Traditional machine learning paradigm struggles to capture intricate features, in which case deep learning paradigm comes to the rescue, which is defined as a subdomain of biologically inspired artificial neural networks with multiple layers stacked on top of each other for hierarchical representation learning. In comparison to traditional machine learning, these architectures are termed as black box solutions or only provide small regions of gray areas that only provide little interpretability or explainability. So this is a trade-off that one has to make depending on the application they are working on. Last but not least, I want to populate this diagram with data science. Well, data science actually borrows some algorithms from all these very specialized domains for pre-processing the raw data, including uh, collection, cleaning, analyzing, visualizing, and explaining data to extract valuable insights for informed decisions. So this was all about a comprehensive definition of AI as promised and their subcategories. Just to summarize this video, artificial intelligence refers to a broad collection of algorithms, paradigms, and techniques designed to simulate aspects of human intelligence using both traditional symbolic approaches, including rule-based systems, logic, knowledge representation, and state-space search, as well as data-driven paradigms like machine learning and deep learning. So in order to build large AI-powered systems, most of these categories or paradigms would be employed in some capacity. After taking this mini course on AI, you would understand that AI would make you smarter because without that intelligence, you would not be able to build large systems. So that was it for today. Our much awaited comprehensive definition of artificial intelligence and its categories. In the next video, we will talk about historical evolution of AI and some key breakthroughs that made much of the impact. If you haven't subscribed yet, your subscription encourages us to make more videos to share our experience, to simplify and shorten your learning path. So see you soon. Stay tuned.